Thanks a lot, Eric. Coming up next, we have Jose Nazario with Arbor Networks. He's going to talk about DDoS attack trends over the last few years. Jose.
Thanks. Hello. What's that? I'm just saying something. That's all. No, there's no laptop switcheroo going on whatsoever. So, being aware of the fact that I'm standing between you and lunch, and myself and lunch, I will do my best to stay on time. As introduced, I'm Jose Nazario with Arbor Networks. I've been with Arbor now, actually about 10 years this spring, working on some data. In this case, we're working on a bunch of data from our Atlas providers and the like, some of whom are in the room. I want to say thank you very much for that. Very much appreciated. It's giving us tremendous insights, I think, into the problem, and we do share it out in forums like this and continuously in our Atlas portal so that we can make sure that we are all basically staying on top of the problem. So in this talk, I'm going to talk about 3 different major data sets. The first is actual attack traffic that comes out of our anonymized statistics. So these are Arbor peak flow systems operated by folks like yourselves and others around the world that have voluntarily decided to submit anonymized data. The upside and downside is pretty obvious. The upside is it's global. It gives us a very wide view. The downside is it's a rather self-selected group, meaning we are sort of biased in some places and weak in others and oversampling in some places and the like. All those sort of classic problems you might expect. Second data source I'm going to be talking about in some of this data here is from a project we have, a long-running project my team has been running called Delayed Runner. This is an active botnet tracking project where we actually impersonate bots using Python code, recording the commands, looking at the intended victims and profiling them that way, looking at where the CNCs are, the durations of the attacks and the like. And finally, our worldwide infrastructure security report. The latest edition was actually released this morning. You can get it on our website. This is survey data. So this is, again, global. This is dozens of participants around the world who report several different questions, data about that. And so I'll have some data sprinkled in from there as well. So all different 3 pieces there. For the 2011 survey that just came out this morning, there's some key findings here. Standard line for all of us, right? Any internet operator can be the target for a denial of service attack. People still in 2011, 2012 still are convinced in some cases when it won't affect us, nothing really valuable here. Fact of the matter is basically everybody's a target. We're also seeing that the size and scope of the attacks is increasing, or they continue to grow rather, although the peak size for the year was actually down. I'll talk about that a little bit. We have the first ever reported IPv6 denial of service attack in the wild on a production network that was reported to us, although I cannot independently corroborate. We are seeing attackers, of course, go where the money is. Some things I won't be covering here, so wireless networks and continued uncertainty there, mobile handsets and the like, and then there are, of course, some trust issues across international boundaries. Sort of get to sort of the meat of it, again, keeping us as much as possible on track. So this is a chart showing the motivations that have been inferred out of the attacks, either through reports that have been posted online, email messages received, et cetera, inferring the motivations for the attacker versus the victim. And looking at this chart, the number one is these political and ideological motivations here, topping off to about 35% of the reports that people have talked about here. And of course, the next one being sort of this, what we call nihilism or vandalism, basically just sort of lashing out, if you will. Anybody who knows me knows I'm very, very fascinated by these ideologically or politically motivated attacks, specifically around nation states and cyber and geo-conflict, acting out sort of in the cyber realm. So this, for me, is very fascinating. This isn't necessarily, more Estonia attacks, more Russia versus Georgia kinds of things, but rather driven largely by the anonymous group. So we've seen them sort of striking out continually again and again and again. So again, this is sort of an interesting finding out of the report here as well. I'm sure I have something. You guys are laughing up in front here. What's? Oh, yeah. Yes, yes, the accidental attacks is what these guys are snickering about, because yes, it has happened. I recall an early research project when I first got to Arbor. There was somebody who had configured DSCP, and we saw blowback into our sinkhole during the attack. Very nice little amplification there, and cute. So yeah, this does happen from time to time, and it does indeed occur. This is one of the classic money slides that we always have. Interestingly enough, the peak attack size is down, reported from 100 to 60 gigabits per second. First time, I think, in the entire 10 years I've been at Arbor that we've been reporting this, it's down. So this is sort of fascinating for us. And this is sort of borne out by the data. But again, we're not seeing these 100 gigabytes or plus attacks in the past year. Largest reported in the survey was 60 gigs. Largest measured is about 65, 70 gigs, on par with that. Don't quite know why they're down. So we speculate, I think, in the report that they're increasingly application-centric, where you don't need the bandwidth, increasingly voluntary, and sort of less of these massive botnets that need to be striking. It needs some more investigation, but it's sort of an interesting finding, I thought, that you guys might find interesting. If we look here at the distribution of the sizes, we are basically finding that even though the peak size is down, looking at the sort of the 1 to 10 or greater size of attacks, these are still fairly common, almost 50% or so, large enough to actually disrupt, if not the operator, at least the end customer to a significant degree, involving the ISP, who would have to then filter. These are sort of disruptive. So we talk about these peak sizes, but again, this distribution here, I think is important as well. Looking at the measurements, so the previous two slides were based on survey data. This is now peak flow measurements. If we look at inbound and outbound, we're seeing for the US and Canada across Q2, 3, and 4 of 2011, about 20 gigs per second. Inbound with a peak in Q4 globally of about 50 gigs per second or so inbound, but outbound larger attacks. So we're seeing here US and Canada, and then globally even higher, closer to 80 gigs per second in Q4 in the red. I do apologize for the garish colors. My goal was actually to make sure that it was legible for folks across the room. The automatically chosen color scheme was pretty awful, actually, for visibility. You can see, again, looking at these, at this U.S. sort of dominates Canada, but is sort of dominated by other parts of the world. So an interesting finding that we have here. I think in Q2, it looks like the U.S. more or less had the lead position around the world in outbound attacks, the green bar on the outbound data set. And if we look at another view of the data, this is sizes and durations grouped together in 2011. And we can see here for 10 gig and larger, 8 to 10 gig, 4 to 8 gig, 2 to 4 gig, and 1 gig to 2 gigs. And then, of course, the durations here, 8, 4, 2, 1, and less than 1. We've seen basically that the smaller, longer attacks, as you might expect, sort of dominate, right? These are easier to commit. These are easier to actually affect. But again, we are seeing a pretty decent number of large, heavy attacks, meaning 10 gigs or greater and 8 hours or longer, occurring here. So it's a very fascinating distribution. And this more or less holds up year to year with some minor changes on occasion. This is another view of the data. Again, measurements, and this is month by month, looking at the average monthly size of the attacks in megabits per second. And we're now seeing an average of about 1.1 gigs per second, about 1.1 gigs per second, a little over 1 gig per second as of October 2011. And the line there, sort of just a rough indicator, and certainly not a great linear fit, but rather a decent indicator there showing that they are increasing year on year in the average size as well. So not just the peak size, but also the average size. If we look at what the application layer attacks are, again, this is something that we've seen, we've been talking about for a number of years, is seeing a significant growth here. HTTP GET and post floods are generally sort of what we generally see as being dominant in terms of the number of attacks. These are, of course, supported by the tools. These are going to be easy to commit. What's nice about these is that they reveal the source IP address, so if you're going to go ahead and block by client IP address, you can do it fairly robustly. We actually even break out a few other tools like Loic, Slowlaris, Apache Killer, HTTP Slow Post, that tool that was debuted at OWASP a little over a year ago, all sort of making a decent appearance here. The Loic tools, as you know, are fairly popular with the anonymous guys, have nice signatures to them, real easy, real sort of stupid tools, real easy tools to fingerprint and break. Slowlaris was a attack methodology and tools developed. It's been, interestingly enough, it's actually been broken out and adopted into various different both bots and tools in the past year or so. So we have seen this attack method becoming widely adopted. We're now seeing a slow post attack as well, which is sort of a variant on this, where instead of never ending the request header, they in fact never really finish sending the post data. So you specify, I'm going to send you a very, very large file, and then dribble it out a byte at a time and take your time this way. So we see this on occasion as well. And then Hoik is another anonymous favorite tool. This is a high orbit ion cannon. Again, C#, TCP connections, either HTTP or UDP based socket attacks and random data. Pretty easy to flag and defeat. Other tools include NKiller 2. Again, popular within the anonymous crowd is sort of a non-standard tool. Another tool called Recoil, another attack type called Recoil. We're seeing this. What's interesting is all of those, except for the one in the middle there, that brown bar in the middle, are all HTTP. So we are seeing SIP control floods, interestingly, sort of get popular. Sort of VoIP infrastructure is being attacked and abused here. Interesting to think about, e-commerce being down, but when the phones are down, it's a significantly different situation for customers. People do expect dial tones. If we look at V6, 4% of our respondents talked about finally seeing IPv6 DDoS attacks. 75% said no, and some staggering number of 21% said we don't know for sure. So this is a matter of sort of visibility as well as sort of defining the problem, right? So we are not seeing a tremendous amount of V6 adopted for critical services. We are seeing a V6 rollouts, obviously, as you guys know, or you guys are doing. Even V6 Day didn't see a necessarily large bump in traffic in V6 last year. Who knows what 2012 will bring. But again, we are seeing V6 denial of service attacks finally make their appearance in the wild. And what's interesting is I'm spending a bunch of time looking for V6 specific tools in the attack space, and I found very, very few of them, and none of them really in the wild. We're certainly seeing a couple of them as sort of proof of concepts of the kinds of V6 attacks you could commit, but not seeing a whole lot of effort being put into throwing them into botnets here. And our hypothesis, again, is basically that there's not a whole lot of V6 to strike in terms of mission-critical services, not a whole lot of V6 connectivity, and therefore V6 is not a terribly easy target for these guys to hit, just in terms of accessibility. But in terms of the attack surface, we think it's largely wide open. Not a lot of V6 security services and knowledge out there. We look at another aspect here, again, out of the survey. This is where I spend a lot of my time, is in the operational security community. So I know a bunch of you in the room through these kinds of communities as opposed to the NANO community. So these are things like NSPsec and other things where a lot of things basically get done on a day-to-day basis. So we're seeing fewer than half participants, or rather half the respondents in our survey participating in this, even though they do, a very, very large majority of them, 87%, say, yeah, we do think that these are actually very effective. We get into some reasons why they don't actually participate, some of it being concern about time commitments or approval from their bosses, some of it being expressly denied by company policy of participating and discussing data there. So we do see people participating in their role, but certainly not with official blessing. These are incredibly effective communities and about getting things done. Like I said, a place where I spend a lot of my time, and there's a lot of very dedicated, very smart people in this space working here. And that's what makes them so effective. Attacks basically get taken care of, in some cases, within an hour or so. Very effective places to be. If you're not involved, and over half of people in the survey said that they're not involved, if your organization is, that's great. If you are not involved, you should certainly try to get involved in one way or another, but certainly do know that you're welcome in those communities as well. So with that, I want to basically help bring us back into time here so we can get to lunch on time. So I think we got a few minutes left, but summary here. V6 has finally made an appearance in the Dallas search landscape. First time that we've seen this happen. We are seeing, again, the peak bandwidth is down from 100 gigs per second down to 60, or about 70 or 80 in terms of measurements, 60 reported. We're seeing these HTTP floods and these tools becoming wildly popular. You saw the tool breakout a few slides ago, Loic, Hoik, and the like. And finally, again, sort of for me, the most fascinating aspect, these ideological motivations are now the most prevalent, or perceived to be the most prevalent motivation for these attacks. Again, a tremendously growing feeling out there that basically this is a way to perform what's called a sit-in protest, or sort of argue about differences of opinion. Clearly, they're still illegal. Clearly, they are significantly disruptive in some cases. But, we saw this in the past month or so with, for example, the SOPA and PIPA legislation, as well as the mega upload takedown, significant retaliation strikes against U.S. government and law enforcement agencies in response to that. So this is, I think, a growing concern and significantly going down market, and really affects a lot of people. And with that, I want to say thanks, and I'll take some questions. John.
Hi, Jose. This
Hey,
is John
John.
Kristoff from Team Comrie. Thanks for your presentation. So I have one slide that would be interesting to have, if you don't have the data, maybe for next time for your survey, is what is the response from providers to these attacks? I mean, some perhaps are let the packets fly because they can bill for it, and maybe others, is it up, deal with the upstreams or filter, and so that would be interesting to know how they actually respond to it.
I do have the data. I didn't put the slide in here. It's largely unchanged year to year. In terms of, it's very often basically black hole route. It's very often employ ACLs, maybe take client IP addresses and try and block those individually at the border, reaching out to others on occasion. But by and large, the significant majority are basically take that IP address and drop that traffic at the border for the duration of the attack. Yes.
Eric Zegast, ISC.
Hey, Eric.
When you're talking about the 100 gigabits and seeing a drop, when I looked at that graph, it kind of looked to me like more like 100 gigs was an anomaly, and that generally the trend is still upward. It might be more interesting to see a more granular graph than that, either by quarter or by month or something, just to see if it was just one standout where someone burned it all, use it and they lose it,
That's a good idea. And in fact, one thing I think your idea of breaking it out by quarter goes a long way to sort of determining if it was indeed a bump. Another way of looking at the 100 gigs as the anomaly here, as opposed to 60 gig, would be to look at the distributions and look at, say, the 95th percentile and graph that instead of the absolute max to see if that's much more smooth. I'll probably go back and take that data and analyze it that way, just to determine if that is indeed what's going on, because this is a bit weird to me. We've been hypothesizing and arguing that basically the max is more or less sort of the max transit, commonly available transit interface size, right? So as you either bond tends to get to 40s or you start deploying 100s, that you're basically going to keep filling those pipes if you can, at least once in that year for that max for the year. And this sort of argues against that, if this is indeed a true drop, right? If this is just something else is going on, there's something else limiting that. So it's worth, I think, digging in, and that's probably how I'm going to try to attack it and see if that's what's going on. I think you raise a good point that 2010 might have been the anomaly and not 2011.
Yeah, I'm going to, Edward Crabb, Google. I'm going to echo his point. I think it's great data, obviously, it always is, but it'd be great to see box plots per year.
Yeah.
Basically, box and whisker. Thank you.
Yeah, thanks. I think I brought us back on time.
More questions?
Oh. Yeah.
So Heather Schiller, Verizon, kind of asking on behalf of a colleague. Your data is gathered from your peak flow and TMS that you have deployed at customers. Can you also estimate the volume of traffic that the volume of good traffic that is compared against the DOS attack traffic? So if you have a 10 gig DOS attack, and what the volume of good traffic that's in there as well is.
We do have that data. It does come up in the XML that gets sent up. It's not processed in real time, so I'd have to basically go back and mine the archives, which are more or less incomplete, to make that determination. It's a fascinating idea and something I should probably automate. What it comes down to is, again, the data is there. It would take some effort, I think, to sort of, not a whole lot of code, but probably about 10 lines of code to make it stand out. I don't have it handy, though, what it comes down to.
Hey, Eric Osterwald, Verisign Labs. I really like the presentation. I just had one quick clarifying question on slide 12. I didn't quite understand the scale. It looked like the percentages didn't add up, so I just wanted to understand, like 72%, 37%. So, like, what were the percentages of?
So it's basically which of the following have you seen in the past year? Not necessarily pick one, but check all that apply. So it's percent respondents, not so. Yeah. Thanks.
All right, thanks a lot, everyone. If I haven't mentioned it yet, there is a survey out there on the webpage. SoftLayer has donated some fantastic prizes, Wacom's, Kindles, digital frames, oh my. We'll be back here at 2:30 for another set of lightning talks and a great talk by Arenesis about a mysterious incident on the internet from last November. Thanks a lot.